Welcome. Last time I discussed some of the rules of differentiation, in, in particular linearity and the power rule. This is sufficient to differentiate any polynomial. So we will see how we can differentiate polynomials efficiently by using what we know so far. Any polynomial when written in standard form is a sum of terms, each of which is a constant coefficient times some power. So for example, the polynomial here is 3x power 5 minus 7x cubed plus 9x squared minus 13. Differentiation distributes or addition and subtraction. So I can distribute this d by dx over the four terms. So I get d by dx of 3x power 5 minus d by dx of 7x cubed, so on. For each term here, like 3x power 5 is a constant, in this case 3 times a power, x power 5. We know that we can pull constants out of differentiation. So derivative of 3x power 5 is 3 times the derivative of x power 5. Derivative of x power 5 can be found using the power rule. It's 5 times x to the power 5 minus 1, or 5 times x power 4. So derivative of 3x power 5 is 3 times 5x power 4. We are going to do the similar calculation for each of the remaining 3 terms. The next term I have negative 7 times derivative of x cubed, that's 3x to the power 3 minus 1, or 3x squared. Then I have plus 9, derivative of x squared is 2 times x to the power 2 minus 1, or 2x. The last term is a constant, derivative of a constant function is 0. So I get minus 0. Of course, we can simplify this and write this a polynomial in standard form. 3 times 5x power 4 is 15x power 4. And then I have minus 21x squared, and finally plus 18x. With some experience, you can almost do this in your head. So let me show you how we can quickly run through this. This time we are going to have a variable with a different name. Name of the variable doesn't matter as long as the variable with respect to which we are differentiating matches the variable used in the function, in the expression. So here we are differentiating with respect to t, the function 4t power 7 minus 7t power 4 minus 8t squared plus 5. I will just go through this term by term and apply the power rule in each term. The first term is 4t power 7. 4 is a constant factor, so I keep it as it is. Derivative of t power 7 is 7t to the power 7 minus 1, or 7t squared. And then minus 7 times derivative of t power 4, that's 4t cubed. And then minus 8 times 2t, 2t is the derivative of t squared. Plus 5 at the end is a constant term, its derivative is 0. Now if I do the multiplications, I get 28t power 6 minus 28t cubed minus 16t. That's the derivative of the given function. So this also means that now I can find equations of tangent lines to graphs of polynomials. Because the slope of the tangent is just the value of the derivative. And if I have an expression for the derivative, all I have to do is evaluate it to find the slope. As an illustration, I'm going to find the equation of the tangent line to the graph of y equals x power 4 minus 4x cubed plus 12x squared minus 7x plus 1 at the point 1, 3. We'll start by finding derivative of the function. We'll go through this term by term again, find the derivative term by term. First term is x power 4, its derivative is 4x cubed. Second term is minus 4x cubed, its derivative is minus 4 times 3x squared, or negative 12x squared. Third term is 12x squared, its derivative is 12 times 2x, or 24x. And then I have minus 7x, its derivative is negative 7 times 1, or just negative 7. The last term is a constant term, its derivative is 0. So the derivative of the function giving the graph is 4x cubed minus 12x squared plus 24x minus 7. Slope of the tangent is the value of this when x is equal to 1. I will sometimes use this notation to mean evaluate this function or expression at this number. In other words, just plug in x equal to 1 into the expression for this, and that's going to give me 4 times 1 cubed minus 12 times 1 squared plus 24 times 1 minus 7, which you can verify comes out to be 9. So this tells me the tangent line has slope 9. It also passes through the point 1, 3. So in point slope form, the equation will be y minus 3 equals 9 times x minus 1. You can also do somewhat more complicated examples by keeping these ideas in mind. There are problems where they ask you to find points on a graph where the tangent line satisfies a condition. A simple version of this is where we find where the tangent line is horizontal. These are somewhat special points on a graph, as you will see in chapter 13. So it's a foretaste of something we will do quite often in chapter 13. So, of course, the derivative tells me the slope of the tangent line. So I have to rephrase the given question in terms of the slope. A straight line is horizontal if the slope is 0. So this question just asks, find the points on the graph of that function where the slope is 0. Slope of the tangent line is the derivative. So it's simply asking us then to find the derivative and find when that's 0. We'll start by finding the derivative. Derivative of 2x cubed is 6x squared. Derivative of minus 6x squared is minus 12x. Derivative of minus 18x is minus 18. So now I can restate the problem as simple algebra problem. Find when 6x squared minus 12x minus 18 is 0. So in other words, set that equal to 0 and solve for x. Since it's a quadratic, I can solve by factoring. I'm going to factor out the 6. That gives me the other factor as x squared minus 2x minus 3. And x squared minus 2x minus 3 factors as x minus 3 times x plus 1. So it's 0 when x is 3 or x is negative 1. Now to answer the question in the way it was asked, I have to find the points on the graph. So I have to find the y coordinates of these points. If x is 3, y will be whatever I get by plugging in 3 for x, namely 2 times 3 cubed minus 6 times 3 squared minus 18 times 3, which is negative 54. And if x is negative 1, then I get 2 times negative 1 cubed minus 6 times negative 1 squared minus 18 times negative 1, that's 10. So the points are 3, negative 54 and negative 1, 10. I will stop here. We'll talk about applying the power rule to slightly more general situations next time.